Brought to you by Connect.js, Atlanta's premier JavaScript conference. Sponsored in part by FeatherDirect. Need a mobile app? Contact us for your custom mobile solution.
Hey guys, I'm going to go ahead and get started since it's rather late already. I really appreciate you all staying around to come hear me talk. Granted, I know probably every single one of you, your bosses were like, listen, if there's one session at that conference you need to attend to justify my sending you here, it's about 8-bit music. So, well, I actually suggested to Pratik, I said, well, this session I've done it before, and it works great at the end of the day because it's like, this is the fun stuff. Before it was all about work. Now this is about like doing something, using my programming skills to do something fun, right? So anyway, a little bit about me before I get started, since most of you probably don't know who I am. I work at a company called Telerik. We're actually a sponsor here. We're giving away like some of the giveaways that they're giving, a tablet and some Android watches and stuff like that. If you haven't heard of Telerik, you might have heard of Kendo UI, which is a framework we have. So that's a popular one. We also have the Telerik platform, which is like allows you to do like it's a whole array of services and platform around mobile development for hybrid and stuff like that. And I run a site called the Telerik Developer Network, which is basically just like a developer site. It's not purely focused on Telerik products. We do a lot of stuff about JavaScript and about mobile web development and things like that. And I co-edit a weekly newsletter called Mobile Web Weekly, which is run by Peter Cooper, which is, any of you know who Peter Cooper is? He has a weekly empire. JavaScript Weekly, HTML5 Weekly, the Mobile Web Weekly, everything weekly. Anyway, if you're interested in mobile web topics, please sign up for that newsletter. One thing that's not there, I'm not a musician. And on the one hand, that plays into like, we'll talk a little bit about some music theory and stuff like that, and keep in mind that I'm talking about this from a very, you know, kind of, I don't have an expertise in music or any particular knowledge of music theory. On the other hand, in some ways that's beneficial because it turns out that your knowledge of music isn't all that helpful to using the Web Audio API to make music, because it's quite complicated. So I know it's hard to see, but all those little things, that's all the Web Audio API. And I show this because the Web Audio API is pretty big. It's got a lot of pieces. What I'm going to be talking about today are only those 3 pieces highlighted in yellow, which are the audio context, which is kind of anything you do in web audio is going to deal in audio context. I'm going to talk a little bit about a lot about the oscillator node and a little bit about the gain node. But the Web Audio API is pretty massive. You can do a lot with it. We're just going to do one particular thing with it that uses these pieces. So a little bit about basics of 8-bit audio. So I'm sure if you're in this session, you're probably some level of a video game fan, especially the old school stuff, right? So you know, you remember there's different pieces of how they used to make this music back in the days of 8-bit audio on your NES and stuff like that. First of all, there's different waveforms, and there are 4 basic waveforms, and then there are a whole bunch of like you can make any kind of waveform. But the 4 basic waveforms made up a lot of the music. And those were basically, there's a sine wave, which sounds like this. And then there's a square wave, which sounds like this. And the way so we'll get into a little bit about how you do this, but you know, you obviously can set the frequency of a waveform to change the note. So you can make it low, make it high, right? There's a triangle wave, which sounds a little bit like the sine on this speaker set. Doesn't sound that different from the sine wave. And the sawtooth has that buzzy sound. You can have a lot of fun with this. Come on, stop! All right, we're going to force it to stop. jQuery did not listen to me. No event there. All right, where were we? All right. So this is how we did that little demo there of the wave files. So basically, and we'll go through this in a little more detail. So it's not a lot of code. I'm using jQuery just to kind of do the selectors and stuff, but the rest is just pure web audio. But let's go through it in a little more detail. First, as I said before, anything with web audio, you have to create an audio context. And so in my non-musician mind, I think of this as like, when you see it, if you've ever been in a music studio, you have all this stuff, and at some point it all plugs into one central mixer that goes out to the speakers, right? And so your audio context is kind of like that connector that goes out from the mixer out to the speakers. And so everything you do within web audio has to exist within with this audio context. So in our case, we're going to be creating lots of oscillators that are all going to be connected to the audio context. But you'll create things like gains that connect to the audio context and so on. So you have to always start by creating an audio context. Next, we're creating oscillators. Oscillators are what produce those wave forms that we listen to. So we just use the method create oscillator within our audio context, and I set that to a variable here. And then I'm going to tell it a type. So as I showed you, there are those 4 basic types, which are kind of pre-built into oscillators. So I can just say, set the type to sine, set it to square, set it to sawtooth, set it to triangle. Or I can provide a custom waveform, which if you're really into, if you have a knowledge of how to do this, you can create all different kinds of sounds. We'll talk a little bit more about that later and what you can do with that. And then I would set the frequency of that particular oscillator. So in this case, I'm setting it to and I'll show you how I figured out what those values are. But this is where I'm talking about your music knowledge doesn't have a lot of value here because, well, you probably didn't know that C4 and this particular tuning would amount to 261.63. That's usually not in your musical knowledge, but that's how you have to create notes in web audio. So at this point, then, my oscillator is ready. I've set the frequency, and then I just need to tell it to start. And I'm providing that 0 because I'm saying there's no delay in starting it. Start it immediately. That's going to play a lot, an important part when we get later into sequencing these notes. And so that 0 is an important thing, but I'll kind of save that discussion for later so as not to confuse you here. Now I'm connecting it to my context. I'm connecting it. I just connect my oscillator to the audio context destination, and this is basically that will allow it to start playing. So when I tell it to start, it's actually the oscillator starting, but you wouldn't hear anything until it's connected to the audio context. It's almost like you plugged it into the amp, and okay, now it's going out, right? And then I could tell it to stop. Again, I can provide a 0, like this is stop right away. I can give a different number that would give it a delay of stop it in X number of seconds, so on. So we've got this oscillator we can play, but we need to set notes if we're going to play music, right? So what this is a particular tuning. It's kind of your standard tuning, equal temperament tuning, and again, I don't know a lot about different tunings, but this is the basics. If you wanted to do a song, you have to create some kind of mapping that maps particular notes to frequencies so that you don't constantly have to be trying to figure out what frequency to set it at. So I found this by basically looking it up. It's just an array that sets different different note names to the actual note frequency that they would need to be played on the oscillator. So now that I know the frequencies I need to set it at, and I know how to create an oscillator, I can actually create notes of any particular, like a keyboard here with particular notes. So I can do that, I can change the type. It's pretty easy to do that. Again, this is the code. We'll kind of go through it really quickly here. Basically, when you click the key, I'm going to look up on that mapping what frequency that key maps to, because each of those keys on that little keyboard are mapped to like a name of a note. So and then I look up the frequency and I start playing it. You'll see that I'm playing the frequency here, and then I'm saying, starting it right at the current time. This is important. Turn the volume down. Do I have control over the volume? Yeah. Oh, that volume, that audio. Okay. I didn't know if it was the mic volume. Sorry. Okay, so I'm setting it to play this particular frequency, and I'm saying at this particular time. And the reason this is because I'm using a single oscillator here, and I'm reusing the same oscillator to change the notes. And it's one of those, there's some weird things when you get into web audio that you're just not expecting. In this particular case, if I were to just say set the frequency, like using that set value, like value.frequency, you'd get this dezippering effect where it would, instead of playing the note, like starting the frequency right away, it would transition down or up to that note. So it would go like, or that kind of thing. Like as I was doing on the earlier, it would do that by default. So you'd set the frequency and it'd do that. So what I'm doing here is instead using the frequency at the time, which is the current time that we're at any particular, like when the note's playing. So I'm going to sidetrack here and explain to you what that means. So basically, when you start playing the web audio, imagine if any of you ever used like any kind of audio program for sound mixing and stuff like that, and you start playing and there's this timeline that just kind of that keeps moving and moving. Essentially, that's happening behind the scenes. You just can't see it. So if I don't say at the current time, basically, if I don't constantly set it at the current time, that timeline's moving, and it's basically, you're going to get weird things happen when you know, that, because that's, sorry, I'm flustering myself here as I'm trying to explain this. Basically, that timeline keeps moving regardless of whether you see it or not. So you got every time you set the note or you set a volume or things like that, you have to consider that time, you have to set it at the current time. In my initial attempts at this, I got really weird things happening when I would change the note, or I would change, you know, I would try and stop the note, or even play the note, and it wouldn't happen because I wasn't considering the time at which I was currently in. And it's one of these weird things that you get into with web audio that kind of messes you up. But it starts to make more sense when you start trying to sequence things and you're thinking about their position within time, right? Like I'm playing a note for this long and so on and so forth, and I need to sequence all these pieces together. That's when it starts making sense that you can kind of see that you know, invisible line moving across this time where I need to play this note at this time. Anyway, so that's why I'm using the set value at time and then changing the frequency that way. And you'll see I've also used the gain. That's just basically tells it how loud. It's a value between 0 and 1, 0 being there's no volume and 1 being maximum volume, right? So it's almost like a percentage there. And then here you'll notice that when rather than stop the note, than using that stop method, I'm actually setting the gain value to 0, and I'm stopping the note later. So when I set the gain value to 0, the oscillator is actually still running in the background. You're just not hearing it, which is fine. Oscillators are inexpensive. So and the reason I do that is because there's a problem, which we'll look at in the next example, which is that by default, if I just stop it, you'll get a little bit of a click noise, like which you can kind of hear it there. You hear when it ends, which doesn't sound so terrible here, but if you're sequencing notes together, this sounds awful, right? So you have to actually fix that by doing a number of different things. In this case, I'm just using stop. But to fix that, and here I'm going to use, that was using different oscillators, by the way. And the reason you'd want to use different oscillators is if I use a single oscillator, I can't have multiple notes playing at the same time, right? So I'm going to use basically every note is a new oscillator, because as I said, oscillators are cheap. So if I want to make a whole song, I need to have multiple notes playing at multiple times. So I'm just going to create an oscillator for each note that needs to play. So in this case, I'm going to do the different notes with each with their own oscillator, but I'm going to get rid of that clip. So you can hear there's that little clip sound is gone, right? And the way that we do that is by, in this case, I'm actually using, as I said, you can set the gain to 0. So I'm starting it, and I set the gain value to 0 here. But there's more interesting ways to do that, which is using this linear ramped value at time, which basically, rather than just a hard stop, I can transition the gain down to 0. Even that can happen really quickly in like microseconds, or it can happen right away. It can happen really slowly, where you transition the note down to a particular volume. So those are additional methods that you can give you control over the gain and can help you get rid of that clipping noise and things that you would get by default. So now we can create different oscillators for different notes, and we can play all those notes, whatever note we want. So we're getting a little bit closer to actually being able to create a song. But now I need to set the length of a note, right? So I need to not just play the note on the keyboard, but I need to be able to sequence these. And the start of sequencing that would be setting the length of a note. So in very simplistic terms, basically, and by the way, I'm not going to cover complex time signatures because I don't even understand complex time signatures. So I'm just going to cover basic time signatures. So in the basic 4/4, 3/4 time signatures, a note, you have 4 beats per measure. And you're playing at a particular, you can say, okay, I'm going to play at 120 beats per minute. And I have 4 beats per measure. And then I can figure out, well, okay, each of the notes is equal to a number of beats, right, effectively. So a whole note would be all 4, half note would be 2, and so on, right? 16th note is a quarter, right? And then I can figure out using just some simple math, like, okay, it's 120 beats per minute, and I have, the 4 beats, and how many seconds that, basically I'm trying to figure out how many seconds that note needs to play for, or in many cases actually fractions of a second. So I take the tempo, I divide it by 60 to give me the how many beats per second, right? And then I'm going to basically multiply that times the length of the note and so on. It sounds more complicated than it really is. This formula basically looks like this, which is that, I'm taking the beats per minute divided by 60, multiplying by the note length, right? Pretty simple. And then I can determine the length of a note. So in this case, I've got the same keyboard I set up before, but this one will play based on the note length. So I have the different note lengths here. And I know if any musicians here, I'm not dealing in dotted or triplets or anything yet. It's just the basics. Right, so I want to play a whole note, so that would be the whole note played at 120 beats per minute, right? So if I were to change that, say, to 160, it's hard to tell here, but it should be a little bit faster, right? And if I then, did a quarter note, obviously, a little bit faster, and so on, right? So that's the 16th note at 160 beats per minute. And it's not, the code for this is not all that different from before. The main difference being that rather than just stopping it with a start of 0, first of all, I'm starting and stopping with that 0. I'm starting it with the current time. So that's saying, if you remember before, we were talking about that play head just keeps moving. In this case, I need to make sure that note starts at whatever point in time the playhead is at. And then I'm saying stop it, but rather than stop immediately, stop at whatever our current time is plus whatever I've calculated the length of the note is in seconds or fractions of a second, right? Which is that play length formula here, right? And then you'll see I'm doing something a little bit tricky here. So I'm saying, I'm setting the gain at this particular time, right? And then I'm ramping down to 0 very, very quickly in 0.01 seconds, right? And the reason for that is to get, so if I were to sequence these together, remember I need to get rid of that clipping noise. So I'm just going to ramp the volume down on every single note that I play, down very quickly to 0. So to your ear, you really don't notice it. It sounds like the note just ends, but actually it's just very quickly going down to 0, and it gets rid of that clip, right? So other than that, the code remains the same. So now that we know how to create a note of a particular length, we then need to sequence these notes together to make a tune, right? Which means that not everything will start at the current time. We're going to need to sequence them so that, you know, we start the song at the current time, and then each note within that song will be at a particular time in the song, basically. So I'm going to say, like, okay, you know, maybe the second note of the song would start with a 2-second delay, and then would end with 2 seconds plus the length of that note. And again, this is getting back to that time thing. It gets, this is the description of dealing with it on the documentation, which webplatform.org actually has, in my opinion, the better documentation on the Web Audio API. But again, I've already explained a little bit, but it's like in GarageBand when you hit play and that playhead just keeps moving. And even if your song's ended, the playhead keeps moving until you've stopped it and moved it back, which you can do, right? So it's important when you're sequencing these songs to always understand that that playhead is always moving. So now I can, with that understanding, I can start to sequence these notes together. So I could do, like, you know, whole note here, quarter note here, and then we'll do, you know. So I could sequence them, so I put these notes in, right? Beautiful, right? It's awesome. I know. I told you I'm not a musician. But I could do something a little more fun, like say this. Right? So that's a start. It's a start getting closer. It's been a lot of effort to get to this point. And honestly, those of you who know that song know that it's not that simple, right? I only took one. This is now basically one set of notes. I'm not actually making the chords and stuff that make up that full song, right? So I then need to take all of that and start making multiple sequences, and it gets, you can imagine the code for this is just really, really difficult. Thankfully, somebody's done that for me. There's a guy who created a library called Band.js. And what Band.js does is it basically, it's a wrapper around this aspect of the Web Audio API. It makes it a lot simpler to sequence this music and to create notes and things like that, and create, you know, different types of instruments and so on. So I'm going to show you a little bit of how that works and how we can then transition what we did all manually into doing that using Band.js. So in Band.js has, you create this kind of, he always calls it a conductor, but it's basically, you create an instance of Band.js, and that's going to manage all the music you create within it. And then I'm going to set the time signature. So his will handle whatever time signatures. As before I was saying, like the math I was showing you and so on was only really for basic simple time signatures. He'll handle basically any time signature. So, and then I set the tempo, which is all the basics we covered earlier, more or less the same, just with an API around it. And I'm going to create an instrument. In this case, I can use the same sine wave, like oscillators that I showed you earlier, the sine wave, the square wave, the triangle, sawtooth, and so on. The nice thing is, what he's done is he's basically created a class called like instruments that is a wrapper around that, so that I don't have to use just the basic oscillators. He's got even one pre-built in there called noises, which is the example, that's the second example there. I don't know if you can see it very well, but anyway, so you can create like white, pink, brown, brownie, and red noises. And I'll show you what that's useful for later. But you could create your own instruments if you're so inclined. So if you just basically got to duplicate his classes. If you want to create your own waveforms and create your own instruments within Band.js, you can do that. So once I've created my instrument, I then just add notes to it. And this is much easier. This is where like your knowledge of music would actually apply now, because I don't need to know the frequencies. I just need to know the note names and the length. And his handles like things like dotted notes, triplets, and so on. So you can pretty much recreate any song that you need to. Also, the one at the bottom there is handling a tie, so you can do ties. As well, you can add rests. My code earlier, I didn't really get into it, but it did add a rest, which is pretty simple to add, but you can, this handles it for you by just using the .rest method. Once you've added all your notes, you tell Band.js finish the song and then just play. So this is the same keyboard, same example as before. I'll just pre-fill it because you don't really, right? It's playing a little bit faster there, but just the important thing here is how the code has changed. Basically what I'm doing in this case is I'm just throwing everything into an array and then spitting it into, once it's done, I spit into Band.js. I just add notes, whatever notes you added to that array, I add to Band.js, finish up my song, click play. It's hard to tell from here, from just staring at this, but it's actually quite a bit simpler than the old code. Now, obviously, that just recreates the same example we did before. The fun thing is when you can now use this to create a full song. This is one that I did when I first learned of this library. It took me a long time because, as I said, I don't know a lot. Reading music was just, years ago I used to know how to read music. This time I was like sitting there, I'm like looking at this thing, what each note was, and like, okay, that's that, trying to compare because I really couldn't read it, but it just took me forever, but it was a lot of fun anyway. Hopefully some of you recognize the song. So I can pause it, which I couldn't do before. I can unpause it. And if I stop it, it goes back to the beginning. So, not only have I kind of now have an API that makes it a lot easier, and I can just my knowledge of music allows me to just write these chiptunes or whatever you want to call it, simply in JavaScript, but I get different convenience methods like the ability to pause and stop and so on to create a little player for it. So looking at the code that does that, and we'll just look at pieces of it because it's actually quite long. Again, I'm creating my new instance of Band.js. I'm setting the tempo and setting the time signature. In this case, I'm just setting, you could call them whatever I want. In this case, it's left hand and right hand, just because the way that the score would set up, basically there was left hand, right hand, so I just kind of called it that. You could call it whatever you want. You can have more than 2 instruments. You could have as many as you want. And then I go about adding all the notes. The one tricky part about this, by the way, is that when you get to a full song, it gets ridiculous. So the JavaScript, I think this ended up being like 400 lines of JavaScript just to create this one song. So what I ended up doing was just kind of splitting things up by measure, so it was easier to see. Because one of the tricky parts that I ran into was that even it was a lot of copy paste and just changing things, but then finding where you heard that one note was off and finding it in 300 lines of code was really, really bad, like difficult. So what I did was I broke it up by bar, left hand, right hand, so it was a little bit easier to figure out where in the song I was. Because this is just a snippet of the code. I'm going to actually show you, whoops, nope, that's not what I meant to do. I want to get out of full screen mode here. So this is basically the full one. As you can see, it's a little bit hard. It's a little bit tedious to to get, to do the full code for the whole thing. So once I've added all those notes, tell it to finish up, and then I can just click, say play, pause, so on, and stop. Pretty easy after that point. The hard part is just getting the notes in there. Right? Now, if you were actually going to create a player, you wouldn't write a whole JavaScript file for each song. If you wanted to, like, say, maybe use this in game or just, create some kind of player that loaded up different songs, you'd want an easier way to load those up. So thankfully, Band.js supports a JSON format. It doesn't take away the tedium of actually writing it, but it allows you just to kind of have all these files and then just load it in. So the JSON format looks somewhat like this. This is basically the song setup. Looks similar to the way you do it in JavaScript. You set up your left hand, right hand with the oscillators and so on. Set up your time signature, your tempo. And then the format looks like this. It gets really long. There's actually multiple formats it supports. When I first started using this, he had all of this in there with pipe delimiters. And I found that while it was short, it was impossible to read. So I was the one who I rewrote his JSON format because I'm like, I can't read this. It's in, like sure I can write it really quickly, but only if I really, really knew what I was doing. And being able to find an error was nearly impossible when you had all your notes delimited by pipes. So I changed it, so this is more verbose, but it's actually easier to read and easier to find your mistakes and things like that. I won't show you the full code, but you can imagine this is still pretty long. And then from there, it's basically the same. I just load in the JSON, rather than just adding notes. I just go load that JSON, finish the song, and play. Here's one. Remember how I said earlier that you can have different instruments, and there was one built in called that was called noises. And noises will essentially recreate that rhythm that portion of the songs that you'd heard in your classic 8-bit music. So this is by the guy who created the library Band.js, Cody Lundquist, and you'll hear the noises used here. So noises are that background percussion. I know, for those of you who don't know that song, right? Most of you don't know. I know. You all know that song, of course. So the noises is basically the same as you would create any notes. One of the things that a convenience method he adds in here, though, is this repeat start. Which essentially, because most of the rhythm section is the same, it just repeats a loop. So rather than have to add the notes for that entire loop continuously, he adds this repeat start, so I can say, okay, just repeat this particular section a certain number of times. So that's basically it. Write all these down right now. So this is just a list of references. The one thing I'd say, if you want to get into using web audio for this kind of stuff, or if you just want to get into using web audio in general, there is a lot of documentation on web audio for your basic loading sounds and playing them, and creating things like audio feedback or playing back samples to create music and so on. This portion of it, using oscillators and stuff, is a lot newer to the Web Audio API. And there's not a lot of documentation, and even the documentation that's out there is kind of outdated at this point. So for instance, I gave the session back early in the year, and then I've given now the session a couple times this month. And between then, I had to rewrite whole portions of it because that API has changed. So it's still somewhat in flux, and so a lot of these tutorials, while they're good, you have to keep that in mind because some of them are old and have the old APIs and stuff. And I'll make however they let me, I'll make these available so you can get these links. Anyway, that's basically it. As I said, it was just fun stuff. If you're into music and if you love old video games, it's just kind of fun. You can get Band.js and write some songs. There's actually sites that have the scores for a lot of those songs out there. So that's how I found Zelda. I just searched up the score and pulled it up and started, doing it. I won't say that writing your 8-bit tunes in JavaScript is necessarily the most convenient way to do it, but it is kind of fun. So, anybody have any questions? No questions. Sure. Yeah, it looked like a real score. That's why I said I had to sit there, and I can't read music very well, and sit there and transcribe it into JavaScript, which is why it takes a little bit of time, but it was fun to create it, and you get part of the fun of this was actually not just in creating the chiptunes, but that library is a lot of fun if you want to dig around and understand how the web audio API works with oscillators and with gain and things like that. So it does not. You kind of have to. So most of the sites that had the scores also had the actual recordings of the original songs as well. So you could listen to it and kind of hear what you wanted to play back and so on. All right. Well, anyway, as I said, this was just intended to be a fun way to end your day. Now you can go back to your bosses and tell them about how you learned 8-bit music. They spent their money wisely sending you here, and I'll see you all hopefully for beers afterwards. If anybody has any questions, feel free to contact me. That's my contact information, or just grab me later. All right, thanks.